So, let us take the last and the fourth derivative of the carboxylic acids. This is called acid amides, RCONH2. So, we have originally RCOOH, that was in the carboxylic acid. This OH, if you can suitably replace by a NH2 group, and these are called acid amides. Quite a number of times you may too say only amides also. Whereas, in the case of acid chlorides, you cannot say only chlorides. Chlorides means alkyl chlorides also will come. Therefore, acid is a must in the case of acid chlorides and acid anhydrides. Esters and amides, oftenly they can be said as only esters and only amides, because there is no other ordinary amides. Amide means acid amide also same one. So, therefore, whether you say acid or not, it is nothing but the acid amide only. So, acid amides will contain a RCONH2 function. Their nomenclature will be up to this carbon, just like we say alk in the case of the carbonyl compounds also, we use this, including this carbon we say alk. Similar the case in the acid amides also, up to this is the root word alk, alk plus an plus amide. So, these three parts will be there in the system. However, if there is a double bond in the alkyl system, it can be an enamide and so on, depending upon. So, if R is equals to hydrogen also, there will be one carbon. Therefore, one carbon means methanamide. The first member of the amide will be the formic acid, or the one carbon amide is known as methanamide. One carbon methanamide, commonly known as formic acid amide, therefore formamide. If two carbons are there, similarly it is called acetamide, commonly known as acetamide, but systematically two carbons are there, ethanamide. Ethanamide is the systematic name, and acetamide is the common name. This is common name. Here formamide is the common name. Ethanamide, two carbons are there, systematically eth, then followed by the an, then amide. Amide is the functional group we are coding. So, therefore, ethanamide. Okay. And similarly, aromatic benzoic acid amide, benzamide, and so on also we can name it. Now, let us go for the preparation of these amide. Preparation methods of these acid amides. The first method is from the direct method, that is using the carboxylic acid, take the corresponding carboxylic acid, add ammonia. You won't get directly the amide, but initially you will get a RCOO minus and NH4 plus, and ammonium corresponding salt will be formed. Like for example, acetic acid is taken, ammonium acetate, a solid is formed. This solid you go on heat it, you may call it as a pyrolysis reaction. So, that is go on merry heating, the solid melts and then undergoes a loss of water, that O and H2 will be coming out. So, first water will be going on distilling out. Later, the amide will be formed in the flask, even that melts and distill out. So, this is called amide. So, to get this amide, so initially you take the carboxylic acid, add ammonia, this must be concentrated one. If it is a dilute one, and much of the time will go for the evaporation of water only, because you must take a highly ammonia is a gas actually, but in the form of gas generally not available in the market. Ammonia will be water dissolved solution is available, but take the highly concentrated the ammonia, that ammonia you add it, you will get a solid ammonium salt. That solid on go on heating, first initially liquid will be there, evaporate some water, then you will get solid. That solid on heating becomes melts, and then pyrolysis breaks up into water and amide. Water goes first and then amide melts and then amide distills, and around 210 degrees or so the acetic acid amide can be prepared. Like this from the carboxylic acid directly the amides can be prepared, or from the other derivatives. the concept already we have discussed very much. The other derivatives like 1, 2, 3 all can be readily convertible into the 4, because the concept 1, 2, 3 concept I said, one is a acid halide, chloride let us take, 2 is acid anhydrides, OCOR, 3 is acid esters. All these compounds readily convert into their corresponding amides. The amides happens to be the derivative number 4. So, 1, 2, 3 can be readily converted either by adding only ammonia or by adding its salt, like potassium salt of the amide KNH2 minus. So, or sodium amide or ammonium salt of amide. So, that NH2 minus will replace this subsequently, that successfully this particular the weaker base will go out and stronger base will come in, and this is called what? Ammonolysis of the acid chloride, ammonolysis of anhydrides and ammonolysis of the esters. All three can be converted into their corresponding amide. This is by replacement reaction or by ammonolysis reaction we can prepare the amides. Amides also can be prepared by partial hydrolysis. Partial hydrolysis of alkyl cyanides. Take the alkyl cyanides, add a aqueous solution of sodium hydroxide in presence of H2O2. You can call it as a alkaline hydrogen peroxide, a solution of sodium hydroxide mixed to the hydrogen peroxide. This is called alkaline hydrogen peroxide, a unique reagent perhaps. It has their own the properties, but in the organic chemistry it is the only one place I am using. So, this is alkaline hydrogen peroxide will partly hydrate actually the plus of water taking place, hydration taking place, and you will get the N will be added H and here OH will be added. This compound happens to be enol. So, tautomerizes to give the amide, and there the reaction stops. In fact, if this is treated with only aqueous NaOH, aqueous NaOH alone, if it is added and boiled for some time, you will get this amide, and that totally undergoes hydrolysis. You will get the carboxylic acid and the ammonia will be liberated. You find ammonia gas will be coming out, the total nitrogen will be detached. So, do not entertain this type of the reaction, the whole concept is lost. Now, we have to retain this nitrogen and we have to convert that Cn into CONH2. This is only possible by this particular partial hydrolysis or treatment of this alkaline hydrogen peroxide, convert this cyanide into the RCONH2. Now, let us go for some of the properties of amides. As we have seen in the general introduction, the amides are the most stable products among this series of the acid chlorides, anhydrides, esters and amides. Amides are the more stable one and less reactive. So, therefore, they cannot be converted into the other derivatives. 1, 2, 3 cannot be prepared from the 4. It is not possible. Amides are fourth number, isn't it? So, from 4 you cannot prepare either 1 or 2 or 3. This type of conversions are not allowed or forbidden conversions in fact. So, therefore, the conversion of 4 into 1, 2, 3 is not possible, but however, hydrolysis will take place, not readily, but continuous boiling with the alkaline or acidic medium for some extent is allowed. So, that is RCONH2. If you take sodium hydroxide aqueous, water dissolved sodium hydroxide, take it and go on boil for some time. When you boil it, it undergoes breakage and add H and OH. So, this side you will get the carboxylic acid, the other side you will get the ammonia. When you use the basic medium, you have one advantage. in the basic medium, the formed ammonia is also a base. This is also a base. Base repulsion will be there. Therefore, the moment ammonia formed will be expelled out. So, the moment you take amide and then boil with the sodium hydroxide, from the test tube mouth you find the ammonia gas will be coming out. But how do you recognize that the ammonia gas is coming? Because ammonia has no color is there, but it has some odor is there. So, the ammonia liberation can be identified by the one is smell. The smell of the ammonia is pungent. So, it has got a pungent smell. So, therefore, by seeing this particular smell, that is, once if you see the ammonium hydroxide bottle smell, you can remember what is exactly the pungent smell. So, the pungent smell will be there, therefore, by seeing the smell one can identify. Then second one immediately that a red red litmus paper. That is, you take a red litmus paper and wet it with the water. Dry one may not be the immediately changes, but wet, make it wet and then expose to the ammonia gas coming from the test tube. You will be that red litmus changes into the blue color. This is a litmus test in fact. Blue changes to red means it is an acid, is HCl is coming out. When ammonia is coming, blue, red changes into the blue. This is the for the basic for all the bases turns, it's not exactly the ammonia. You can also go for the another test called the ammonia smell. When it is coming, you expose a rod, dip it in the concentrated HCl. When concentrated HCl dipped rod, when exposed to the flames of ammonia, a white dense ammonium chloride will be formed. This will have a white dense fumes will be there. So, you will be getting a huge amounts of white dense fumes are formed. Take a glass rod, dip in concentrated HCl and expose to the test tube in which we are doing the reaction. From this ammonia gas is coming, isn't it? So, expose this glass rod to this fumes. There you find a white dense fumes because of the formation of the ammonia is coming. You expose to HCl and ammonia react, ammonium chloride is formed. But fortunately ammonium chloride is solid. So, therefore, from the vicinity of the glass rod, the entire this cloud, the dense white dense cloud is formed. This is because of the ammonium chloride formation. However, soon it will disperse into the air. So, you do not find after some time this white, the cloud will be dispersed just like cloud diffuses in the air, isn't it. So, like that the white will be removed however, but initially you may get a immediate formation of that white dense cloud will be the test. Lastly, you have another test called a Nessler's reagent. Nessler's test. So, you take a Nessler's reagent and add this the ammonia, that is gas fumes, only fumes, not the solution, just the fumes you allow into the other test tube containing the Nessler's tube, that only fumes will be allowed. Then close the test tube and shake it well, that Nessler's reagent will become into the red color precipitate, red brownish color precipitate is formed. This is called Nessler's test. So, due to this Nessler's test or this anyone you can relay, all are excellent. But as the 1, 2, 3, 4, the fourth one is more authentic test for the inorganic the salt analysis. This last one is more important, but anyone you can. But this test is common even to the cyanides also. Cyanide also with the same reagent will liberate the ammonia. So, thereby the ammonia, that is alkyl cyanides and alkyl amides, you cannot differentiate by this particular boiling with the NaOH. Both gives the carboxylic acid and ammonia. This also carboxylic acid and ammonia comes. So, the other compounds like for example, RNH2 is there. These are called 1 degree amine. This will not liberate this ammonia gas. If you boil with sodium hydroxide, nothing happens with this amine, no ammonia gas will come. So, there you can have a differentiation of amide from the NH2 using this aqueous NaOH test. Amides has a one important reaction, that is called a Hoffman's Hoffman's bromoamide. Hoffman's bromoamide rearrangement. This is a very important reaction also, several times asked in the JEE examination with different types and all that. So, this reaction is called Hoffman's bromoamide, means amide with bromine, meaning is it brominated amide. So, sometimes Hoffman's rearrangement or Hoffman's reaction. Hoffman has got half a dozen of the contributions, therefore, to specify this specifically we call Hoffman's bromamide rearrangement. Sometimes people also say the compound will become short, bigger compound will become small. So, therefore, it is also called Hoffman's degradation. Hoffman's degradation. There is a Hoffman's elimination is there, Hoffman's rules are there, different reactions are there. But this is specifically, that is why called Hoffman's bromoamide rearrangement. In this reaction, the RCONH2 is going to be converted into the RNH2 with the help of the bromine and some base like sodium hydroxide or potassium hydroxide, and for some time you have to heat also. Okay. This is the main reaction. An amide converts into amide. This is an acid amide, okay, called acid amide in general. This is called 1 degree amine. If 2 R's are there in ammonia, that is 2 degree amine. So, specifically the product formed is a 1 degree amine comes. This conversion is known as Hoffman's bromamide rearrangement. In this reaction, so the bromine and the KOH are the base can be we have an option of KOH or NaOH or any other strong bases available can be, but the bromine cannot have any replacement. Only the bromine will react. If the chlorine and the fluorine, some other halogens are used, may other oxidation takes place, but not this type of the conversion. What exactly the mechanism is taking place? Let us see. When the mechanism has got a number of questions. So, first you take one common amide. This amide is going to react with the bromine first. So, one of the bromine will enter into the NH, the HBr will be going out. So, the compound will become into a RCON with bromine and the hydrogen plus HBr is formed. So, one bromine goes out into the compound. This HBr is an acid. So, that is what the acid formation and the base will neutralize, you will get the salt and water. So, for this reaction the base is a favorable one, because in this reaction one acid is formed, the acid reacts with sodium hydroxide, right. So, therefore, in the basic reaction the forward reaction will be favorable, because the acid formed get neutralized. So, this compound once again now reacts with directly with the base, like for example, if I take sodium hydroxide, Na plus and the OH minus, the OH minus will take away the now the H plus. So, the base has got another role now, it will take away the hydrogen from the N, leaving the electron pair to the nitrogen only, isn't it. So, it will become a minus now. The Na plus will take away the Br with the minus 2 electrons will be with the electrons it will be taken. So, from here what is happening means removal of the H plus, removal of the Br minus. So, HBr already one HBr is lost, isn't it. Now, another HBr is removed from the same nitrogen. So, that the amide will become into a nitrogen with original lone pair. This original lone pair will be there as it is. Another lone pair is formed from the hydrogen removal, H plus removal. So, one more pair is formed, but this goes a pair is lost, therefore, a vacant orbital is formed. In fact, this pair minus, this box is plus, minus plus you can write it also. Such a type of the carbon is called carbene. In the case of nitrogen it is called nitrene. So, this is called acet group, so acyl group otherwise. So, call it as a acyl nitrene. So, this intermediate compound is known as acyl nitrene is formed, very unstable one. So, the R taking the 2 electrons just like in the other reactions several places, like in the Arndt synthesis we have seen, R minus is migrating with 2 electrons into the vacant orbital. This one of this lone pair makes a bond formation. So, what happens is now this is original CO, the NC will get a double bond and this R is formed here. Okay. So, this will become now a original lone pair, one pair will be as it is. Now, R will be having a NCO bond. This is called another intermediate product called alkyl isocyanate, alkyl isocyanate, ATE, alkyl isocyanate. Now, this compound undergoes now the hydrolysis with the base like KOH. You can also use water and hydrolyze also. Otherwise, are H and OK and H and OK. This part you will get K2CO3. Potassium carbonate is formed. So, twice you use H this side, OK, H, OK, R, add HOH, HOH. Make this side formic acid, then neutralize with KOH, you will get the potassium carbonate only. That side you will get the N with the 2 hydrogens and with the 1 R group. This is called 1 degree amine. So, this is the final compound. However, so we have a 3 prominent intermediate compounds. One is N-bromoamide. This is nothing but the amide with bromine extra. So, the first intermediate is called N-bromoamide. Second intermediate compound is acyl nitrene, a nitrene containing a RCO. R can be CH3, then you say acetyl nitrene, benzoyl nitrene and so on. In fact, then immediately then next this step is actually rearrangement step. So, all the steps may be written exactly where the rearrangement taking place means this step the R is jumping, isn't it, from leaving this carbon reaching the another nitrogen internally from here to here. We have not added a new group or removed a old group, just rearrange it, that's all. So, this step is exactly the rearrangement step. In this rearrangement, acyl nitrene is converted to alkyl isocyanate. If this alkyl is methyl, okay, CH3, if R is equals to, that is this R is equals to CH3, this will become a CH3NCO, isn't it, CH3NCO. This is called methyl isocyanate. This is what popularly known as MIC gas, and it was also the reason for the Bhopal tragedy. So, this MIC gas is also called Bhopal gas. However, in Bhopal, this due to this gas, so many people died long back, however, around 25 years back, that was a calamity. The gas leaked out through a pesticide company, and midnight several people died because of the poisonous nature of this gas. So, this was popularized by the Bhopal tragedy gas, right. So, this is nothing but the methyl, not cyanide, isocyanate, methyl isocyanate. CN is cyanide, NC is isocyanate, NCO is there, that too. So, therefore, cyanate it is, alkyl isocyanate or methyl isocyanate is the MIC gas that on hydrolysis gives the 1 degree amine. So, finally, an amide convert into the amide, 1 degree amine is known as Hoffman's bromamide rearrangement. Wonderful, the examples are there. One such example I can quote here, a benzoic acid amide, for example, CONH2 under this Hoffman rearrangement. This gives a aniline, because the net reaction is what, the CO disappears, that is all, okay, aniline comes. So, benzamide will give the aniline, benzamide will give the aniline. This is the one example. You too can have one more example. A benzoic acid containing the acid on the both the sides is called phthalic acid. Phthalic acid amide from the both the side is called phthalimide. This phthalimide undergoes this Hoffman rearrangement to give the benzene plus. So, this will become, actually you better write it as a benzoic acid plus amide. The amide will become into 1 degree amine. So, acid will be acetate. This is called orthoaminobenzoic acid, has a common name called anthranylic acid. This is called orthoaminobenzoic acid or orthocarboxylic aniline, either way you can say. Generally, the carboxylic acid given a preference, therefore, it is called as a benzoic acid containing a orthoamino. So, this orthoaminobenzoic acid is commonly known as antranilic acid. So, how you get this one means first you hydrolyze it to 1,2-acid and this side to amide. This amide will give amine, isn't it? So, therefore, do not get confused. First you hydrolyze it, make into acid and amide. The amide will become 1-degree amine. Acid is already there. So, therefore, the phthalic acid will give the orthoaminobenzoic acid. This is one unique example. Benzamide giving the aniline in the case of aromatic case. Aliphatic case, acetamide will give methylamine, propanamide will give ethanamine. One carbon less. See, this carbon is missing in the answer. So, whatever the long chain you take, let us say pentanoic acid amide, pentanamide will give butyl amine. One carbon less amine is going to come. That carbon is liberated as actually CO2. Later it is carboxylic acid, isn't it? The corresponding formic acid, that is carbonic acid. The carbonic acid comes out as a salt actually, K2CO3. If it is labeled, let us say this C double bond O carbon is labeled with C14, we get a potassium carbonate. Labeled carbon you find in the potassium carbonate as a salt, it will come out. So, that is the one wonderful reaction of this one, but the amides are the quite a number of products that is in our body. The entire our body is a polyamide system. So, the amides have got a very good stability towards the several reagents like dilute acids and the dilute bases. They will not that simply hydrolyze unless you go on boil for the with the concentrated bases, they will be hydrolyzed. So, amides have a lot of role in biologically, and the amides, however, one important reaction is this Huffman's bromide rearrangement.